Okay, so we're back to the WOW videos now. This is line 22f1fa19c3k10 hydrogen carbonate ion H2CO3 Boron Trifluoride 5G WOW Seti. It's part 284c3k10. So this is the WOW Seti 1977 radio signal, the alien radio signal that we're studying. There's the mathematical equation and the answer that brought up this data, okay? So August 14, 2012 is when I was doing the research on it, and today's September 13th, about a month later. My thoughts: the cross-reference effervescence leads to carbonic acid. Wiki quotes all the data. Carbonic acid 3D balls, that's what they look like. Here's another graph. It says carbon dioxide solution, dihydrogen, carbonate, acid of air, aryl acid, hydromethoic acid. There's the properties. And here's bicarbonate. There's the graph for that. There's the name for it. Hydrogen carbonate. And there's all the different numbers and stuff for it. We'll just skip over that. Okay, so quote from Wiki. In organic chemistry, bicarbonate IUPAC recommended nomenclature hydrogen carbonate is an intermediate form in the deprotonation of carbonic acid. It is an anion with the chemical formula HC03. Bicarbonate serves a crucial biochemical role in the physiological pH buffering system. The chemical properties: the bicarbonate ion, hydrogen carbonate ion, is an anion with the empirical formula HCO3 and a molecular mass of 61.01 daltons. It consists of one central carbon atom surrounded by 3 oxygen atoms in a trigonal planar arrangement with a hydrogen atom attached to one of the oxygens. It is isoelectronic with the nitric acid HNO3. The bicarbonate ion carries a -1 formal charge and is the conjugate base of carbonic acid H2CO3. It is the conjugate acid of CO2. The carbonate ion is shown by these equilibrium reactions. So there's the calculations there. Quote, a bicarbonate salt forms when a positively charged ion attaches to the negatively charged oxygen atoms of the ion, forming an ionic compound. Many bicarbonates are soluble in water at standard temperature and pressure. In particular, sodium bicarbonate contributes to total dissolved solids, a common parameter for assessing water quality. There's a graph there. Structure of boron trifluoride, an example of molecule with trigonal planar geometry. Wiki quotes. Boron trifluoride is the chemical compound with the formula BF3. This pungent, colorless, toxic gas forms white fumes in moist air. It is a useful Lewis acid and a versatile building block for other boron compounds. So I'm going to Google Lewis acid. The term Lewis acid refers to a definition of acid published by Gilbert N. Lewis in 1923. Specifically, an acid substance is one which can employ an electron lone pair from another molecule in completing the stable group of one of its own atoms. Thus, H+ is a Lewis acid since it can accept a lone pair completing its stable form, which requires 2 electrons. So I'm going to Google boron. Boron polymers in ceramics play specialized roles as high-strength, lightweight, structural, and refractory materials. Boron is similar to carbon in its capability to form stable, covalently bonded molecular networks. These were the keywords that I found while looking through the boron. Take a look at this thing here. So this is a Poincare ball model view of the icosahedral honeycomb in hyperbolic 3 space. Isn't that cool? And here's a great icosahedron. My thoughts: this reminds me of the core of the UFO spaceship, how it floats in the middle of the spinning triangular shape, icosahedron. So you would put these 2 together. You have this in the middle and this around it. Idealized structure of a compound with trigonal planar coordination geometry. Trigonal planar molecular geometry. I'm going to look it up from Wiki. In chemistry, trigonal planar is a molecular geometry model with one atom at the center and three atoms at the corners of a triangle, called peripheral atoms, all in one plane. In an ideal trigonal planar species, all three ligands are identical and all bond angles are 120 degrees. Such species belong to the point group D3H. Molecules where the three ligands are not identical, such as H2CO, deviate from this idealized geometry. Examples of molecules with trigonal planar geometry include boron trifluoride BF3, formaldehyde, H2CO, phosgene, COCI2, and sulfur trioxide SO3. Some ions with trigonal planar geometry include nitrate NO3, carbonate ion CO3 and guanidinium CnH2 plus. In organic chemistry, planar three-connected carbon centers that are trigonal planar are often described as having sp2 hybridization. Nitrogen inversion is the distortion of pyramidal amines through a transition state that is trigonal planar. Pyramidalization is a distortion of this molecular shape towards a tetrahedral molecular geometry. One way to observe the distortion is the pyramidal alchemies. Whew, a lot of big words there. September 13, 2012. The formula from the keywords: hydrogenate carbon atom plus 3 oxygen atoms plus trigonal planar plus isoelectronic plus HNO3 plus bicarbonate ion plus negative plus conjugate base plus ion plus equilibrium plus reactions plus bicarbonate salt plus positively charged ion plus attaches plus negatively charged oxygen atoms of the ion plus forms plus ionic compound. Bicarbonates plus soluble plus water plus standard temperature plus pressure plus dissolved solids. Plus boron trifluoride plus chemical compound plus formula plus BF3 plus gas plus white fumes plus moist air plus Lewis acid, which I'm going to Google to see what it is, plus building block plus boron compounds. This is all going to continue in the next video. Basically, it's the research with the formulas. Thank you for watching.